Let us see one practice example on a cyclic encoder with different generator polynomial. So in short, we are going to finish this video because we have already seen the details of cyclic encoder. So the generator polynomial is given as x raised to 4 plus x cube plus x square plus 1. So you know this structure. So you have to draw this structure. This is output switch, feedback switch. This we have already seen and explained about it. So let us see. So the generator polynomial has degree 4. So it has 4 flip-flops. 1, 0, 1, 2, 3. Then after that, this line, I have already told you that this line corresponds to x raised to 4 coefficient, that is 1. Or if x raised to 4 highest degree is there, highest degree's coefficient is 1, it is always there. Then x cube is there, so this line appears, x4, then x cube, then x square line is also there. X is not there, x coefficient is 0, so this line is not there. Then 1, for 1 this line is there. So after that we will see the equations. Now see, flip-flop 0 input, flip-flop 0 input, this is the input to the flip-flop 0, so that is equal to this one. So this input, so this is coming here, here and here. So these lines, this one, this one, this one and this one is nothing but flip-flop 0 input, because that is coming to the flip-flop 0 input. So that is equal to flip-flop 3 output plus message input. So flip-flop 3 output plus message input. So the flip-flop 0 input is M, that is message, plus flip-flop 3 output. What is flip-flop 1 input? That is equal to flip-flop 0 output. What is flip-flop 2 input? That is equal to this line. Now this line I have told you, this is equal to flip-flop 0 input. Same. So that is equal to flip-flop 0 input and flip-flop 1 output. Then flip-flop 3 input, flip-flop 3 input is equal to flip-flop 0 input plus flip-flop 2 output, because this line, this line, this line and this line is nothing but flip-flop 0 input. So flip-flop 3 input is equal to flip-flop 0 input plus flip-flop 2 output. So flip-flop 2 output plus flip-flop 0 input. So same is written here, that when message enters into the circuit, feedback switch is closed, the message enters into the circuit, then parity bits are generated. At that time output switch, firstly output switch is at position 2, so message bits enters in the output as well as in the circuit. Then after that output switch is connected to pole 1 and feedback switch is open, and parity bits, calculated parity bits will appear at the output switch. That we have already explained in the previous videos. So let us see this table. So we have these equations. So input is for the message 110 we have to calculate. So the message is 11. So you have to write first message M, then flip-flop 0, flip-flop 1, flip-flop 2, flip-flop 3. So initially when message is not there, message bits are not there, or ideal initial situation, flip-flop 0, 1, 2, 3 has 0 bits, bit 0. Okay, after that flip-flop 0 input. Input means present row. The row you are calculating is nothing but input, and the output is previous row. So flip-flop 0 input is equal to M plus flip-flop 3 output. So M is 1 plus flip-flop 3 output means previous row. 0 plus 1 is 1. Now what is flip-flop 1 input? Flip-flop 1 input, you have to calculate this one. So that is equal to flip-flop 0 output. So this one. So what is flip-flop 2 input? Flip-flop 2 input is you have to calculate this. Flip-flop 2 input is flip-flop 1 output. So flip-flop 1 output means previous row, flip-flop 1 output plus flip-flop 0 input. So 1 plus 0, 1. So what is flip-flop 3 input? Flip-flop 3 input is flip-flop 2 output, this one, plus flip-flop 0 input. So this one. So 1 plus 0, 1. So let us calculate for this one. So flip-flop 0 input is equal to flip-flop m plus flip-flop 3 output. So m is this one, 1 plus flip-flop 3 output, 1 plus 1, 1 plus 1, 0. Then flip-flop 1 input is flip-flop 0 output. So this will be here, flip-flop 0 output, this one means previous row. Then flip-flop 2 input is flip-flop 0 input plus flip-flop 1 output. So 0 plus 0, 0. Flip-flop 3 output, flip-flop 3 input is equal to this, this you have to calculate for that. Flip-flop 0 input plus flip-flop 2 output. So 1 plus 0, this one. After that 1 1 0, message is 1 1 0, so this 0. So now you understood the equations or operations. So let us calculate for this. So this is the case. Suppose you have to calculate this one, this row. You have calculated up to what? Up to this much you have calculated. So you have to calculate this row. So flip-flop 0 input, that means this row is equal to this 1 plus 0, that is equal to 1, this one. After that flip-flop 1 input or this row is equal to this flip-flop 0 output. So this 0 appears here. Now for this you have to do flip-flop 0 input plus flip-flop 1 output, 1 plus 1, 0. Now for this you have to do flip-flop 0 input 1 plus flip-flop 2 output, 1 plus 0, that is equal to 1. So for writing you have to write the code word. For that, message is 110. So first write message 110, and the sequence is from flip-flop 3 to flip-flop 0. So 1 0 0 1, because firstly the output comes parity output. So or you can see this circuit, flip-flop 3 output will appear first. That's why you have to write flip-flop 3 output. So 1 0 0 1.